You have to know that yourself. No, that's H. That's Libethin, that's sodium. There's no, they don't mix it.
On the textbook it says H2O.
That's a different periodic table. But that's not the one.
No, there's only one periodic table, but the different elements can bond together differently.
So is H2O on it? Because it's only H2O above.
Elements are, on the periodic table, there's only atoms.
Only elements that are all by themselves, not bonded together.
So a list of all the atoms?
Exactly, and the way that they're
man-made, natural.
exactly, and the way that they're organized. You got it. They're individual, based on the number of protons and electrons. They can be organized based on that.
I thought they were organized on the. I'm confused. Organized on the electrons because it was like one. No, they're on all.
Well, protons are always equal to electrons, and so they're You could say that they're organized.
Because plus 4, that's how many electrons. No, if it's plus 4, which is
Protons are positive energy, then neutrons are neutral energy, no electrical charge, and then electrons negative energy.
Excellent, excellent. Yes.
This is much more fun than third grade.
Good. You remembered some things. That's good, though.
But they're all. Can I just say that? Well, I kind of did Wednesday. Really good.
All right, gentlemen. So full and the box empty. Jared, do you have to measure the box again? No, because the volume of the box, the height, the width, and the length did not change. Very good. And what did you discover through experimentation was inside the box? How were your guesses?
Well, we guessed a lot less stuff. We guessed seeds and like a magnet and yeah.
But there were a lot of things in there. So now you can see how difficult it is for scientists to figure out what's inside a cell or what's inside an atom. You know, they have to make good, educated guesses. We'll study that. So smart. But you know, those elements are easy to organize once they figured them out. So we'll talk about that. Good job. Keep going. Ladies, so what are you finding out?
We found that C has the most water because. Wait, is this A? I think is this A, B, C?
You decide. A, B, C. Okay.
You think this has the most water because it has greater volume?
You think it has greater volume? Okay. Because it looks wider. Okay, so you're looking at the volume of the water, right?
Right.
The red colored water?
Yeah.
So you think that this one here has more, okay?
Yeah.
No, isn't it like one of the 6?
Does everyone agree?
Yeah. I said that they all have the same amount of water, just the shape of the bottle. Like if they have more or less.
Ah, now what do you base on that? How do you base that?
If it's taller, it's thinner, so the water's going to rise up.
So you must stop playing chess with my grandma.
More wide, it's going to go.
Periodic table. Like your granddaddy can help you teach
in
that.
any-
This is what I say. I didn't know.
Gentlemen, so what do we know about water? What does water do when it goes into a container?
It spreads the water molecules. The water molecules split.
Okay.
The liquid in there.
Well, they spread, right? They don't split. Okay. So I think that Isabel is onto something. How could you test whether or not some of you are right and there's more water in the bigger jar, and Isabel's theory? Oh, okay. So why don't you do that and test who's right? Good job.
The 12 paper cups until there wasn't a drop left. Because the volume of the lemonade in the pitcher and the lemonade in the 12 paper cups put together the same or different.
And what did you say?
We said the volume is the same because it is the same amount split up into different parts. It's the same amount of lemonade. Yeah.
So are you saying that I could take any solid thing or any whole liquid thing and I could cut it into 1,000,000 parts and I would still have the same volume?
Yes.
For that item?
Like we were saying, like it's like fractions. Like it could be 2 billion, 4 millions, or a half, and they're the same.
Good. Very good.
22 billion. Sam, you guys done? This is what I got.
There are 4 different states of matter: solid, liquid, gas, and plasma. Solids are hard, liquids can run, gas can expand, and plasma's in the sun.
Very nicely. What are you learning?
That we can turn a liquid into gas by heating it strongly.
You can turn...
A liquid into gas by heating it strongly.
Okay. What's an example of that every day that people do? Turning a liquid into gas?
Like making spaghetti.
Now how...
Like, because when you're boiling the water.
Okay, good. So what part of that is gas?
The steam.
The steam. Okay. The steam. Very good. Anything else that you've learned?
So far, particles aren't as close. And then, like, gas can expand because the particles are all, like,
Farther apart.
yeah, and then solid is solid because they're all together.
All right. Very good. Keep it up. When it asked you to measure the length, the width, and the height to determine its volume when it was empty and when it was full, did you measure it twice?
No.
Why?
Because it's going to be the same thing. Because it's the same size.
So the box is the same size regardless of how much is inside. So what changed? The mass changed. So how does this compare to a ping pong ball and a golf ball?
Well, because different.
Yeah, the ping pong ball barely made a splash, but the golf ball, it was like a waterfall.
Why?
Because it had more mass.
Okay, good. So right now, what is Grace creating? Is she creating the golf ball or the ping pong ball? The golf ball. She's putting more mass in there, more molecules, more items with molecules to increase the mass. All right, very good. Will the volume be the same?
Yes.
And the mass?
Yes.
Because if you put it all together,
So this is similar to what you said about the lemonade, correct?
yes, yeah.
Dividing the items doesn't change their mass or their volume.
Right.
What would change their mass or their volume?
If you took one of the 4 out. Yeah. Like, if you took one, like, this out.
What if you hollowed the clay out?
Yeah.
What would change, the mass or the volume?
The mass.
Mass.
The mass, because the matter that contained mass would be taken out, therefore reducing the object's mass.
Excellent. But the volume would probably stay the same, right?
Yeah.
Very good.
It will be the same.